Okay, so in this video, we're going to talk about the law of sine. And before we do that, I'm going to go over the area of a triangle with you. And so over here, if I want to compute the area of this triangle right here, you already know the formula, right? Its area is equal to 1/2 base times height. And the reason for it being 1/2 base times height is because the area of a rectangle is base times height, and so a triangle is exactly 1/2 the area of a rectangle. All right, so there's nothing really fancy over here, right? This is the base. If I call that the base, the height is something I want to point out, okay? The height is always the distance from a vertex to the opposite side, but it's the perpendicular distance from the vertex to the opposite side. So here's one possible orientation. I'm going to call this H1, B1, okay? So over here, I'm going to say area is 1/2 H1, B1, okay, subscript. Now, another way of computing this area, right, depending on how you want to draw it, you can call this guy right here base 2, right? If this is base 2, remember I said there's 3 different heights within this triangle, right? You can draw the height from here, from this vertex to this, and you can call this guy right here H2. And so you can say area is 1/2 B2 H2. And then so forth, right? There's actually a third height. You could say, hey, this guy right here is my height. Again, it's the perpendicular distance from this vertice to this base. And then you can call that B3. And you can say area is 1/2 B3 H3. Okay, so all these 3 formulas will give you the area of this triangle. I wanted to show you that there's 3 different heights. The height could be from here to here. It could be from here to here, and then you would call this the base, or it can be from here to here. Again, this has to be the perpendicular distance. That, by definition, is the height of a triangle. Okay, so I mean, there's some more examples here, right? This was an acute triangle, so if you have an obtuse triangle like this, another way of thinking about the area of this triangle right here is to call this guy right here the base, and then this guy right here, it's actually from the vertice all the way down to here, and you can call this guy the height. Again, this is the perpendicular distance from the vertice to an opposite side, where it's a little bit trickier to think of, but that's the way you would find the area of this triangle. It's 1/2 base times height. That formula doesn't change. And over here, I drew that same triangle, and maybe this part right here is confusing you. Like, how is that the height? Or how is that the base? Maybe you want to call this the base. And then remember, if you want to call this the base, right, the height is the perpendicular distance from the vertice to the opposite side. So this guy right here would be the height. Okay, so many different ways of reorienting your triangle, calling different things, different sides, the base, and different heights. Okay, so just remember that the height is the perpendicular distance from a vertice to the opposite side, and you won't get that wrong or anything. Okay, so there's actually derivation for the law of sines, right? This is an acute triangle, but I'm not going to go into the derivation, okay? So you just need to know how to apply it. And if I have an acute triangle right here, right? Triangle A, B, C, what I can do to find the side lengths and the angles, right? If I don't have a right triangle, because up until this point, you learn everything using right triangles, is you can state it like this. You could say the sine of angle A over the side opposite is equal to the sine of angle B over the side opposite is equal to sine of angle C over to the side opposite. Okay, so there's nothing really fancy about this formula. This proportion is always going to be true given a non-right triangle. I should say this applies not only for acute, of course it applies for obtuse triangles. What I really meant to say was that it applies for non-right triangles as well, okay? All right, so if you want to reverse this proportion over here, you could write A over sine A, B over sine B. That is also true, okay? C, little c over capital C. Okay, so your law of sines is helpful for non-right triangles. Okay, so while this formula itself is pretty straightforward and the computation is pretty straightforward, The not straightforward part is when you have those, I guess what they call it, I think they call it the ambiguous case, okay? All right, so if you're given side-side angle, and side-side angle just means you're given two sides and an angle for a given triangle, we'll call it triangle ABC. There's actually four, I would say six possible cases, okay? So I'll break it down by, whether the angle that's given to you is obtuse or acute. And so if an angle that's obtuse, right, an obtuse angle is an angle that's greater than 90 but less than 180. And so this is all in your textbook. I pretty much just copied it down. But what I wanted to point out is that you want to compare the fixed angle that they give you. We'll call this the fixed angle. And we'll call this little a, right, which is always opposite the, the side that's opposite the fixed angle. We'll call this the fixed angle, the side opposite the fixed angle. Okay, and then of course B would be the side adjacent to the fixed angle. So basically, if your side opposite the fixed angle that you're given is less than the adjacent side, right, you can see that you can't even draw this triangle. You can't even bring it down on any point of this side to actually form a triangle. So if the side that's adjacent is greater than or equal to a side that's opposite the fixed angle, you're not going to be able to form a triangle, right? If the side that's opposite the fixed angle, which is A right here, is greater than the adjacent side, then you can form one triangle. And again, with these problems, you could always draw the picture to help you visualize. Now, if angle A is acute, you're going to have four possible cases. The key is computing that height. Remember I told you, how to compute the height a few minutes ago, right? It's the vertice, or distance from a vertice to the opposite side, but it's the perpendicular distance. So you're going to have to compute the height in these problems. So the first thing you want to do is compute the height when you're given an acute triangle, if angle A is acute, I should say. And then what you want to do is compare it to the side opposite the fixed angle. Okay, right? This is the side that's opposite. And then, of course, this is our fixed angle, okay? So these letters, right, in the problems that are given to you in the homework could be anything. So that's why I'm going to use a more generic term. Fixed angle, side opposite the fixed angle, okay? So if the height is greater than the side that's opposite the fixed angle, then you're not going to be able to form a triangle. Again, you can see that this guy cannot be, even if you swing it down, you can't reach this side, right? Likewise, if your height is equal to the side opposite the fixed angle, you're going to have one triangle. In fact, you're going to have exactly a 90-degree triangle. So if H is actually equal to A, right? This is my height. This is also my A, which is opposite my fixed angle. And then the other ambiguous, they call it the ambiguous cases because, you could have one triangle, you have two triangles, you have no triangles, is if your height is less than the side that's opposite the fixed angle, which is also less than the adjacent side, right? Or opposite and adjacent, then you're going to have two triangles. Basically, think of this point right here as a hinge. You could swing this guy over and form an obtuse angle right here, right? This would be an obtuse. So this would be one triangle, and then this would be your other triangle, okay, if you were to draw that separately. And again, you have to compute the height. You're going to have to figure out, I think they pretty much give you the side that's opposite and they give you the adjacent side. You just have to make that comparison. The key is finding that height. And last but not least, right, if your side that's opposite, which is little a right here, opposite your fixed angle, is greater than or equal to your adjacent side, then you can form one triangle. Okay, so these guys right here are really called the ambiguous cases. No triangle, these two right here, no triangles and two triangles. These ones are not that ambiguous because it's just one triangle. Okay, so let's do some examples on finding area first, and then we will, do some examples involving this. All right, so find the area of the triangle round to the nearest tenth. What I always like to do is draw the picture. So just call this your fixed angle, right? Because this is the angle that they give you in the problem. Again, don't confuse these letters with these letters right here because they could mean different things. So try to remember in terms of opposite and fixed and adjacent, okay? So fixed angle, opposite side opposite the fixed angle, and then adjacent, because these letters don't necessarily correspond to these problems. So my fixed angle is angle B, so it's 60 degrees. So roughly draw a 60-degree angle right here. So if this is capital B, right, this guy right here will be little b, okay? And they said little a right here is 19, little c is 14. So it doesn't really matter how you want to draw it, okay? So I'm going to call this guy right here, maybe I'll call this A right here, capital A, and we'll call this 19. So this is, lowercase a, and then little c would be right here. C would be equal to 14, which is capital C's right here. Okay, so there's a rough sketch. Now, had you put A over here and put C over here, your problem is not going to change, okay? The area would still be the same. It's just that your base and your height would be slightly different. Okay, so I'm asked to compute the area, right? The area is 1/2 base times the height. Don't get this B confused with this B, okay? So the base right here, based on how I drew the picture, I want to call this my base. So area is 1/2 14 times the height. Now, I don't know what the height is, right? I can't call 19 the height. The height has to be the perpendicular distance. And so a skill that you have to have in geometry is just to draw the height. If they don't have the height, you draw it. Remember, it's the distance from the vertice to the opposite side, but it has to be the perpendicular distance. Okay, and now to compute that height, right, look at this triangle here located on the left. And you already know your right triangle trigonometry, right? Right triangles are easy because you know how to, your SOHCAHTOA. So I'm going to say sine of, so I'm given a side that is opposite my height, or so I'm giving an angle that's opposite my height. I'm giving a side that's opposite my side right here. So the trig ratio I would use is sine of 60, right, is equal to h over 19. Okay, and make sure, you know, this is actually a number. It just happened to be a number in a unit circle, right? Sine of 60 is √3/2 times 19 is equal to h. And that's going to be your height. Okay, so you can plug that in over here. So this is going to be 7 times √3/2 times 19. All right, that's my height, √3/2 times 19. This whole thing's my height. And then you could enter the units for this. Okay, so you can multiply this on a calculator. I believe when you enter this, you will get 115.2. Okay, and just write units squared. Okay, if they don't give you units, you can just write units squared or square units. Either one's fine. Okay, so again, had you interchanged the A and C, your 19 and 14 would have been flipped, and your answer is not going to be different, okay? The final answer is not going to be different. Your height's going to be slightly different based on how you label this. If that example is a little confusing, let's do one more here. They said C is 29 degrees, so this time right here, I'm going to call it C, which is 29 degrees. And if that's little c, if that's capital C right here, my angle C is 29 degrees. Little c is the side that's opposite, so we'll call this lowercase c. And again, doesn't matter what you want to label. Do you want to call this A? You want to call this A? It does not matter. Okay, so I'm just going to call this guy right here little a, which is 38. And I'm going to call this guy right here little b, which is 31. And that means this is capital A, this is capital B. Okay, so again, I'm asked to find the area of the triangle. So I'm going to call this the base right here, right? Area is 1/2 base times the height. Okay, so this is my base. The height is the perpendicular distance. Okay, so there's my perpendicular distance from the vertice to the opposite side. And to compute the height, right, you see that this is a right triangle. You could say sine of 29, right, opposite over hypotenuse, h over 38. Okay, and then you can cross multiply, right? H is equal to 38 sine 29. Substitute it into there. And then enter this on your calculator. Okay, make sure you are in degree mode when you plug this in. Okay, sine of 29 degrees times 38 is your height. So when you multiply all that out using your calculator, I believe you're going to get 285.6 units squared, or square units. Okay, make sure you always write square units if they don't give you units. And that is how to compute the area of a triangle, just dropping down that height and using some right triangle trig.